it just current law. It just current law, it just voltage law. Today we'll see KVL. Yesterday we had done one problem with this. This is the problem yesterday we have done. So we have to determine the currents. Write down the problem question. Determine the currents I1 and I2. Write down. Determine the currents I1 and I2 for the circuit shown. Yesterday already you had drawn this circuit. Determine the currents I1 and I2 for the circuit shown in figure. So yesterday we have done this problem. What is the value of I1 we have got and I2 we have got? Have you solved the problem for I1 and I2?
Yes, sir.
What is the value of I1?
So I1 30/7.
30/7. I2?
I2 is 10/7.
Okay. So these are the values which we have got yesterday for the current I1 and I2. Yesterday we had discussed how to write the loop equations, how to write the voltage equations. How we have done? What is the first step? In the direction of current, we take plus and minus. Only for resistor, inductor and capacitor. Here inductor and capacitor is not there. That's why I am keeping plus and minus for resistors in the direction of current I1. So in the first loop, in the direction of current I1, I am making plus and minus. Similarly, in the second loop, in the direction of current, I am making plus and minus. Is it clear?
Yes, sir.
Okay. So we have written the loop equation. What is the second step? If current flows from plus to minus, take negative side. If current flows from minus to plus, take positive side. So take the first loop. In the first loop, I1 is the reference. Remember this point. In the second loop, I2 is the reference. So first loop equation, I1 is flowing from minus to plus. Minus to plus means plus 10 volts voltage. The voltage formula is V is equal to I into R. Current I1 is flowing from here. That is, if current is flowing from plus to minus, we will take minus 1 into I1. Resistance multiplied by current is the voltage. First one is voltage, second one is resistance multiplied by current is voltage. From plus to minus. Minus. In the first loop, see I1 direction only. I1 is flowing from plus to minus. If I1 is flowing from plus to minus, we will take minus. Resistance is 2 ohms. Here, what is the current we will take? What is the current we will take there?
I1 minus I2.
I1 minus
I2.
Because in the first loop, I1 is the reference. See, I1 is flowing in the downward direction, but I2 is flowing in the upward direction. Both are in opposite direction. In this resistor, both currents are flowing. So one is in the downward, another is in the upward. So we are taking I1 as the reference. That's why I1 is positive and I2 is negative. If both are in the same direction, if the arrow is in the reverse direction, if both are in the same direction, we will take plus here. Since these two are in opposite direction, we are taking minus here. Okay, we have completed the first loop. That is equal to 0. Similarly, second loop. See the second loop. Second loop, how many elements are there? Elements means resistor, inductor, and capacitor. We are having only three elements: resistor, inductor, and capacitor. Here we are having only resistors. Start from any point. I am starting from plus 3. But in the second loop, you have to see IT only. IT is flowing from plus to minus. Plus to minus means minus. Minus 3. Only current IT is flowing in 3 ohms. Plus to minus. Minus 4. What is the current flowing in 4 ohms? IT. IT is flowing from plus to minus. In the first loop, we have said I1. Here plus to minus, minus is added. Similarly, I2 is also flowing from plus to minus 2 volts. Now, what is the current we had right here?
I2 minus I1.
I2.
I2 minus I1. Because in the second loop, I2 is the reference. In the first loop, I1 is the reference. We have taken I1 minus I2. In the second loop, I2 is the reference. That's why I2 minus I2. If we simplify this, we are getting minus 3I1 plus 2I2 is equal to minus 2. But in the first loop, make I1 positive. If you make I1 positive, then multiply on both sides with minus. So this is the first equation. And second equation is here make I2 positive. Multiply on both sides with minus. Let it be equation 2. If you solve equation 1 and 2, we are getting these values. We are getting these values. Okay. This method of solving the equations and determining the currents I1 and I2 is called Maxwell's loop equation method. The method of solving the currents I1 and I2. This method is called Maxwell's loop because this is one loop. This is the second loop. By using these two loops, we are writing two loop equations. This is the first loop equation. This is second loop equation. Loop means closed path. Loop means closed path. This method is called Maxwell's loop equation. And we have got the currents I1 and I2. The unit for the current is amperes. The unit is very important. Okay. So this is one method for solving the currents. There is one more method.
Sir, it is
Sir,
not
can you
visible,
write
sir.
on left side?
Yes, sir, it's not visible for us.
Not visible? Okay. 1 minute. One minute. Otherwise,
Can you able to see now?
Yes, sir.
On this.
now, Kramer's method. See, same problem. See this problem. Same problem I am doing here. I have to determine I1 line by using Kramer's method or matrix method. Kramer's or matrix method. Okay. Now here, how many loops are there? How many loops are there?
Two loops.
Two loops. So we'll get two-way matrix. In the two loops, we are having two currents, I1 and I2. See here, this is the matrix I am writing. Resistance multiplied by current, that is equal to voltage. Okay. Here, this is the column matrix. I is the column matrix. This is 2 by 2 matrix, resistance matrix. Current is two currents are there, two loops are there, I1 and I2, 2 by 1. Okay, that is equal to V. V is equal to I into R. Here, first I am writing the resistance matrix here. In the first, here the resistance matrix, let us see A11, A12, A21, A2. Four elements are there. Okay. Here four elements are there. A11, A12. Here these are the diagonal elements. These are diagonal elements. Diagonal elements are called self-loop elements. Diagonal elements are called self-loop elements. Now first I will write these diagonal elements. A11 means sum of all resistances in the first loop. A22 means sum of all elements in the second loop. Write down this matrix first of all. Draw this diagram and write down this matrix. Draw this diagram, write down this matrix. Have you written?
Yes, sir.
Yes, sir.
Okay. See diagonal elements A11. The element A11 is equal to sum of only resistances, not the voltage. 10 volts I am not adding, only resistances I am adding.
Sir,
1
have we
plus
got that A11 and A22?
1 plus 2 in the first loop.
Yes.
A22 is equal to 3 resistances are there in the second loop. 2, 3 and 4. That is 9 ohms. Now see here. I am writing here 3 and 9. Next A12. 1 means first loop, 2 means second loop. First loop and second loop. Common element is 2. Where first loop and second loop, common element is 2. But see here, I1 is in the downward direction, I2 is in the upward direction. Since both are in the opposite direction, the common element is 2. Here I am putting minus. Since I1 and I2 are in the opposite direction, we are taking minus. If both are in the same direction, it will take plus. Remember that. Similarly, second loop and first loop. Second loop and first loop element is also 2D. Here also, I1 and I2 both are in the opposite direction. That's why we will take minus. Okay. This is the resistance matrix. A12 and A21 are common elements. A12 and A21 are the common elements. Common loop elements. Common loop elements. Write down that A12 and A21 are the common loop elements. Now we have completed resistance matrix, current matrix. Now come to the voltage matrix. See here, voltage in the first loop. How many voltage sources are there?
One.
Only one.
One, sir.
Only 10 volts is there. That 10 volts is positive or negative? First loop we are seeing. That means we have to see the direction of I1.
I1.
I1, how it is flowing? From
Sir,
negative to positive or positive to negative?
Negative to
Because-
positive.
Negative to
negative to
positive.
positive.
Okay, negative to positive. Current flows from negative to positive will take plus 10.
Positive.
Next, in the second loop, is there any voltage source?
No, sir.
No, sir.
No, sir.
No. That's why it is 0. This is the matrix. Write down that complete matrix in the next step. Write down that matrix. Now I will determine I1 and I2. I1 is equal to delta 1 by delta. I2 is equal to delta 2 by delta. What is delta 1? Delta 1 means replace the first column with voltage values. Delta 2 means replace the second column with voltage values. See, in delta 1, we are replacing the first column with voltage values. On the right side, we are having voltage at 10 and 0 in the first column. But in delta 2, the second column is replaced with 10 and 0 in that matrix, in the resistance matrix. Now determine the determinant. Ten into 9, 90 minus 0. What is the determinant of this matrix? 3 into 9, 9 into 3, 27 minus 4. Minus of minus plus again minus is there. Delta is determinant of that matrix. Next here. What is the determinant? 3 into 0, 0 plus 20 by Is it okay? What is the value?
I1 is 90 by
20 by
23.
23.
I2
90
is
by
23 for
20
I1.
We.
for 90 by 23. This is the I1 and I2 values. See, yesterday we have done one problem. I think you have done the wrong answers. I1 and
Sir,
I2.
I got 20 by 23 only, sir. I2.
Yes, sir.
Yesterday's
Okay,
problem.
I1.
I1 same, sir. 90 by 23 only, sir.
Okay. Then these are the correct values. Yesterday, see here,
Some did mistake. Yes, sir.
by using two equations also you have to get the same answers. That
Okay,
is
sir.
90 by 23,
20 by 23.
20 by 23. These are the correct values. Whether you use the Maxwell's loop equation or Kramer's method, you have to get the same answer.
Sir, the last can you explain again?
Any doubt?
The last step.
Last step, okay. See here, delta 1 means replace the first column with 10 and 0. Second column as it is here. Here delta 2 means replace the second column with 10 and 0. Okay. Now take the determinant. Determinant of this matrix is 10 into 9. 90 minus 2 into 0 is 0. What is determinant? Determinant of this matrix. What is the determinant of this matrix? 9 into 3, 27. Minus 4. Okay, 27 minus 4. 90 by 23. I2 is take determinant of this. 0 plus 20 by 27 minus 4. 20 by 23. Okay. These are the values of I1 and I2. By using matrix method, we will determine the currents like this. Still any doubt? This is called Kramer's method. First method is Maxwell's loop equation method. Have you written?
Yes,
Sir.
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 Now we will go to the definition of KVL. See here, KVL definition. Algebraic sum of voltages. See, this is the voltage, this is voltage, this is voltage. In a loop, write down the definition. KVL definition. Algebraic sum of voltages. Write down the definition for KVL. Algebraic sum of voltages in a loop is equal to 0. Algebraic sum of voltage drops. Algebraic sum of voltage drops. DROPS drops. Voltage drops in a loop is equal to 0. Algebraic sum of voltage drops in a loop is equal to 0. Okay, we'll go to the one more problem. Draw this circuit. Determine the currents I1 and I2 for the circuit shown in figure. Determine the currents I1 and I2 for the circuit shown in figure. Okay, you do one thing, you change the direction of current. Draw the circle. Okay, what is the first step for writing the loop equation?
Sir, I had a doubt.
Tell me.
Sir, aren't we supposed to take the same direction for all loops?
Which one?
Shouldn't we be taking the same direction for both the loops, or can we take different directions also?
In the problem they will give. We are not taking. In exam they will give. They can give in
Okay.
that direction or in the reverse direction.
Oh,
Based on the given direction in the problem, we have to solve accordingly. We are not taking this. In the problem they are giving. We can take any direction. We should not take in the problem they will give. Okay.
okay.
If they are not giving, then we can assume directions. Now see here. The first step is in the direction of current I1 and take it plus and minus. Only for resistors, not for the voltage and current. Similarly, I2 direction is this direction, plus and minus. In the second loop also, I had taken plus and minus only for resistors, but not for the voltage source. Now I will start writing the loop equation by considering if current flows from plus to minus, take negative sign. If it is flowing from minus to plus, take positive. Take the first loop. In the first loop, I1 is the reference. See, I1 is the reference. I1 direction. I1 is flowing from minus to plus. Minus to plus means plus. This is the voltage. Now here voltage is 3 into I1. But I1 is flowing from plus to minus.
Plus to minus 3 I1.
Minus. 3 into current flowing in this is only I1 is flowing in 3. Now, I1 is in the first loop, we have to see only I1 direction. I1 is flowing from plus to minus. Plus to minus means, but in this 2 ohms, two currents are flowing, I1 and I2. See, I1 is in the downward direction. I2 is also in the downward direction. Both are in the same direction. That means I1 plus
I2.
But in the previous problem, both are in opposite direction, I1 and I2. That's why I am taking I1 minus I2 in the first loop. I2 minus I1 in the second loop. Here first loop, I1 plus I2. Both are in the same direction. Now I1 is flowing from plus to minus. See 6 volts. I1 is flowing from plus to minus. Plus to minus means minus 6. We have completed the first loop. That is equal to 0. Is equal to 0 is very important. So many students will not keep is equal to 0. Okay. The definition itself says the algebraic sum of voltage drops in a loop is equal to 0. Now simplify this. Bring all I1 terms minus 3I1 minus 2I1. Minus 5I1. Next, minus 2I1. 4 minus 6 minus 2 is equal to 0. Now make I1 positive. That is 5 into I1 plus 2I2 that is equal to minus 5. plus 2 it becomes, that side it becomes minus 2. This is your first loop equation. Now come to the second loop equation. Start from any point. Let us start from 1 ohm. Here I2 is direction is same. Plus 2 minus. Plus 2 minus means minus 1. What is the current flowing in 1 ohm? I2 is the current flowing in 1 ohm. Now I2 is flowing from plus 2 minus. Plus 2 minus means here we have, in the second loop we have to see only I2 direction. See, I2 is flowing from plus 2 minus in 2 ohms. What is the current in 2 ohms now?
I2 plus I1.
I2 plus
I2
I1.
plus I1.
I2 plus I.
This is I2 plus I1. Because both are in the same direction, I2 and I1. Now I2 is flowing from plus 2 minus. Plus 2 minus means minus.
Negative.
Now I2 is in 3 volts, how I2 is flowing?
Negative. Positive.
Negative to positive.
Negative to positive means
Positive.
Plus 3.
plus 3. Now simplify this. Minus 2 I2 minus 2 minus 1 I2, that is 3 I2. Minus 3 I2 minus 2 I1 minus 3 is equal to 0. Here in the second group, make I2 positive. That is 2 I1 plus 3 I2 is equal to minus 1. Let it be equation 2. Is it 2? Let it be equation 2. Now solve these two equations and tell me I1 and I2. Solve these two equations and tell me I1 and I2. Somebody is asking question that can't we take in clockwise and anti-clockwise? It is not clockwise and anti-clockwise. Based on the given problem, we have to take. In the problem, depending on the direction of current also, the value of current I1 and I2 will change.
So for suppose if it's not given in the question.
If it is not given means we can assume. But definitely they will give in the exam. If they are not giving means
Sir,
everybody will take.
every time from which point we should start?
Not audible. Repeat once again.
From which point should we start always?
Any point. In the loop, we can start at any point. We can take from voltage or resistance, any point we can start for writing loop equation. But at the end, the same equation will be. but we have to start from the direction of current only.
Sir,
Remember this point. Whatever the direction is there in the loop, we have to take that direction only for the current direction. But you can start anywhere. In the direction of current only, we have to take. Okay? For writing loop equation.
sir, is there any procedure for assuming the current direction?
Procedure for current direction.
Assuming current direction, for example,
Assuming current direction, we are not, there is, they will give in the problem. We should not assume the direction. Suppose if you take in your house, current flows in one direction only through wire. It won't flow in the reverse direction. So that is predefined, prefixed. From which point it is starting, that will depend. In the wire, for getting the power to your appliance. Suppose to your fridge is there. Power has to flow from the main switch to your fridge in one direction only. If current flows from fridge to the circuit means it will damage. So direction of the current is fixed. Here in the loop equation, they will give the direction. If they are not giving the direction means we can take any direction, whether it is clockwise or anti-clockwise. That is your wish. If they are not giving.
So is the answer 12 by 11 and 19 by 11? I1, I2.
Okay.
No,
I1 is
-1 and 0, sir.
Sir, I2 is
I
I2
got
I2
minus
is
1 and 0.
-1 and I1 is
Sir,
0, sir.
I1 0, I2
-1.
-1.
I1 0.
Yes,
Yes,
sir.
I1 0 and I2 minus 1.
I2 -1 you are getting?
Yes, sir.
Yes, sir.
Okay. We'll
Yes.
verify the Kramer's method, whether you are getting the same answer or not.
Okay.
Okay, sir.
Sir, I had a doubt, sir. Sir, sir, I had a doubt, sir.
Tell me.
Sir, is there any possible they'll give a 3 loops in the question?
We'll do the next problem.
Oh, okay, sir.
Right now we are doing simple problems, 2 loops. In the next problem, we'll see go for the 3 loops.
Okay,
Okay. Is it okay? Diagonal elements. In the first loop, we are having 3 and 2. In the second loop, we are having 2 and 1 diagonal elements. Diagonal elements are always positive sign. Okay. Now come to the common elements. First loop and second loop common element. Why I am taking +2?
Both I1 and I2 are flowing in the same
Same
direction.
direction.
Both I1 and I2 are in same direction. That's why I am taking +2. Okay. Now come to the first loop voltages. In the first loop, see I1 is flowing from, in 6 volts, how I1 is flowing?
Positive to negative, minus.
In the first loop, we are having 2 voltage sources, -6 and 4. In the second loop, we are having 3 and 6. I2 is flowing from, in the second loop, we are having 2 voltage sources, 6 and 3. I2 is flowing from +2 minus, that's why -6. I2 is flowing from -2 plus, that is +3. We have completed voltage sources now. Now I will simplify this. This is 5. Now see the loop equations. Okay, 1 minute. I have written this. Write the matrix. You write the matrix.
Yes, sir.
Okay. Now I have simplified this. Minus 6 plus 4 is minus 2. Minus 6 plus 3 is minus 3. Now compare the first loop equation, multiply the matrix row by column 5 into I1. See here 5 into I1 plus 2 I2 plus 2 into I1 is equal to 1. Is equal to minus 2. Second equation is 2 into I1 plus 3 into I2 that is equal to minus 3. We will get the same equations. If you multiply the matrices, we will get the same loop equations. See first equation 5I1. 5 into I1 plus 2 into I2 is equal to minus 2. Okay, similarly, second equation 2 into I1 plus 3 into I2 is equal to minus 2. Now we determine the currents. I1 is equal to
We are getting the same answer, sir.
We are getting the same.
Yes, sir.
okay, we will get the same answer. Now we will go to the next problem.
So the left part is not visible.
Okay. Have you completed writing that problem, previous problem?
Yes, sir, finished.
Run this problem.
Sir,
Hello, screen is visible?
yes, sir. Sir, could you tell me the right side voltage value at I3 loop?
8 volts.
Okay.
8 volts. This is 7 volts. Okay. Have you drawn?
Yes.
Yes, sir.
Yes.
Okay. What is the first step?
Loop plus and minus.
Plus
In the
and minus.
direction of currents, we had to take plus and minus. So I1 is flowing like this. Plus, minus. Plus, minus. First loop is completed. Now come to second loop, I2 direction. See I2 direction. This will be plus, this will be minus. This polarity itself indicates here above is plus, here both are opposite direction. Either way. If both here plus minus indicates both are same direction. Now these are opposite direction. I2 is flowing from plus to minus. I2 is flowing from plus in this direction. In this direction. Okay. In the second loop, we have to see only I2 direction. Now come to third loop. Mark those plus and minus in the direction of currents I1, I2, and I3. That is your first step. Now we'll write the loop equations. See here. First we'll take first loop. First loop I1 is reference. If I1 is reference, see I1 is going from minus to plus. Plus 5. I1 is flowing from plus to minus. Plus to minus means minus 1. What is the current in 1 now?
I1.
I1. Okay. Now I1 is flowing from plus to minus. Plus to minus means minus. I1 only you have to see. In the first loop you have to see I1 only. I1 is flowing from plus to minus. That is minus 2. What is the current in this? 2 currents are flowing. But what you write?
Sir,
I1 minus I2.
I1.
I1. Okay. I1 minus I2 because I1 is the reference. First we will take I1.
Mm.
In the first loop. I1 minus I2. And I1 is flowing from plus to minus. Minus.
Minus.
This is voltage. This is 5 is voltage, 6 is voltage. This is current multiplied by resistance is voltage. Resistance multiplied by current is voltage. 5 and 6 are directly voltages. Remaining in the resistor. In 1 ohm resistor, I1 is the current. In 2 ohms resistor, I1 minus I2 is the current. Simplify this. Minus 3I1 plus 2I2 minus 1 is equal to. Make I1 positive by multiplying on both sides with minus. That is 3I1 minus 2I2 is equal to minus. Let it be equation 1. This is your first loop equation. Why I am making I1 positive? In every problem I am making I1 positive in the first loop. In the second loop I2 I am making positive. In the third loop I am making I3
It's
positive.
a
Why?
reference point, sir. I1 is reference in first loop.
Okay, I1 is reference is one reason. Second reason is in the matrix you see. In the matrix if you write, diagonal elements are positive. That's why in the first loop I1 is positive. In the second loop I2 is positive. In the matrix method you see, all the diagonal elements are positive. Okay, that's why I am making I1 positive in the first loop. Okay, now come to the second loop. Start from any point. I2 direction is 6. I am starting from 6. I2 is going from minus to plus 6. I2 is going from plus to minus. You have to see I2 direction only. That is minus 2. I2 is going from plus to minus 2. What is the current? What is the current?
I2 minus I1, sir.
I2 minus I1. From plus to minus. Plus to minus to minus.
Minus
3. What is the current in 3?
I2. I2, sir.
I2. Plus to minus.
Minus
I2 is going from plus to minus. Minus 4.
4.
What is the
4
current?
Okay.
I2 plus I3.
I2 plus I3. See here, I2 is in the downward direction. I3 is also in the downward direction. Both are the same polarity. Plus plus minus. I2 downward direction. I3 downward direction. That is I2 plus I3. That is equal to. We have completed the second loop. Entire second loop is completed. Now simplify. I1, I2, and I3. Minus or minus plus 2 I1. Minus 2 I2 minus 3 5 plus 4 9 minus 9 I2. I3 is there minus 4 I3 plus 6 minus 7, that is minus 1, that is equal to 0. Now make I3 positive in the second way. Multiply the entire equation with minus. Let it be equation 2. Write down the equation. Now I'll write the third equation. I3 is going from minus to plus 8 plus 8 volts. I3 is going from plus to minus 5. What is the current in 5 ohms?
I3, sir.
Okay, I3. Next. I3 is going from plus to minus 4. What
I3
is the
plus
current?
I2. I3 plus
I3
I2.
plus I2. Completed 1, 2, 3 that is equal to 2. Now simplify this. Minus 4 I2 minus 9 I3 is equal to minus 8. But in loop 3, I3 make positive. Make I3 positive. Multiply on both sides with minus. Let it be equation 3. Don't simplify these three equations. It will be very lengthy. We will go for matrix method and we will verify whether these equations are correct or not. We will write the matrix and we will verify the equations, whether they are getting the same equations are there or not in matrix also. Okay. First, we'll write the diagonal elements. What is A11?
1
1
plus 2.
1 plus 2.
Sum of all resistances in the first loop. That is 1 plus 2. Now, what is A2?
2 plus 3 plus 4.
2 plus 3 plus 4. What is A33?
5 plus 4.
4
5
plus
4
5.
plus 5. 4 plus.
Diagonal elements are always positive. There is no plus and minus, only always plus. Okay. Now come to the common elements. A1, first loop and second loop. First loop and second loop. Common element is
Are opposites, so negative.
Negative, sir. Minus 2.
negative minus 2. First loop and third loop. What is the common element for first loop and third loop?
Plus 4. Oh, sorry.
There's no common element.
No
No
Sir,
common element. Means 0. There is no connection in between the first loop and third loop. That's why it is 0. Now similarly, A12 is equal to A2. Second loop and first loop common.
Minus 2.
A12 and A2. Next, second and third loop.
plus 4.
Plus
Is the
4,
value?
sir. Plus 4.
Because both are the same values. Next, A31, third loop, first loop.
0.
0.
0, sir. A13 equal to A31.
This is A3, third and second.
Plus 4.
A13 and A31 are same. A23 and A33 are same. Okay. This is the matrix. Write down the matrix. Since 3 loops are there, it is 3 by 3 matrix. Now here 2 plus 1 is 3. 4 plus 3 plus 3 is 9. 5 plus 4 is also 9. 5 minus 6 is minus 1. Minus 7 plus 6 is minus 1. Now compare the
Minus
first
1.
equation. Okay. Compare the first equation with the matrix 3 into I1 minus 2 into I2. See here first equation. 3 into I1 minus 2 I2. That is equal to what? 3 into I1 minus 2 I2. I3 is not there. That is equal to minus 1. That is equal to minus 2. This is your first equation. See second equation. Minus 2I1 plus 9I2 plus 4I2 minus 2I2 plus 9I2 plus 4I2 is equal to minus 1. Third equation, there is no I1. The third equation is 0 into I1. This is 0 into I1 plus 4 into I2 plus 9 into I3 is equal to 8. So our loop equations are correct. Now we can determine I1, I2, I3. I1 is equal to delta 1 by delta. That is delta 1 minus 1 minus 1 8 minus 2 9 4 0 4 9. I am replacing the first column with voltage sources minus 1 and 8. That is delta 1 by delta. Delta is the determinant of this matrix. Delta is the determinant of the resistance matrix. Okay. Similarly, I2 is equal to replace the second column with voltage sources. And you know how to determine the determinant of the 3 by 3 matrix. You can do it at home. Okay. In this way, you'll determine the currents I1, I2, and I3. Delta 1 means replace the first column with voltage sources. Delta 2 means replace the second column with voltage sources. Delta 3 means replace the third column with voltage sources. Siddharth sir, are you there online? Siddharth sir? Okay. Any one student take the screenshot of the attendance and send it to me in the WhatsApp group. Can any one student? Anyone?
Yes, sir.
Okay. You send me the in the WhatsApp group attendance. Okay. We have completed the mesh analysis or loop analysis. Whatever we have done the problems today, these are mesh analysis, MESH, mesh. Mesh analysis or loop analysis. So in mesh analysis, we are applying KVL principle. In mesh analysis or loop analysis, mesh means closed path. Loop is also called as closed path. In both mesh or loop analysis, we are applying KVL, Kirchhoff's voltage law. And for solving the currents I1, I2, I3, we are using two methods. One is Maxwell's loop equation method, and the one is matrix method, that is Cramer's method. Okay. Okay. Now I am stopping the class here. Attendance, have you taken screenshots?
Yes, sir.
Okay. Thank you. Send me in the WhatsApp group. I am stopping the class here.
Thank you, sir.
Thank you, sir.